Okay, good day everyone. My name is Zuhal and today I would like to do paper review in regards to all-pass filter and its usage. About the main paper. The title is Group Delay Based All-Pass Filter for Abstract Sound Synthesis and Audio Effect Processing. It is published in the 21st International Conference on Digital Audio Effects from the year 2018. Okay, so we will talk about first we will talk about the discrete all-pass filter presented in this paper. The all-pass filter controls group delay trajectories for allowing fine-tuning each frequency of the input signal. The output gain for this filter is unity, meaning the input and output gain of the signal is equal. The transfer function for this filter is this, and the phase response is this. And note that the transfer function presented right here is the transfer function of this of the all-pass filter proposed in this paper. Since all-pass filters control group delay trajectories, the definition of group delay itself is the first derivative of phase in respect to frequency, with the symbol omega here to denote the normalized frequency. Group delay of first order all-pass filter is this. And since the group delay is the first derivative of phase in respect to frequency, the phase response is the first integration of group delay in respect to frequency here. Group delay trajectory can be viewed as a function that maps the frequency axis to set of time delays. There are many types of group delay presented in this paper, but mainly it has three types. The first one is stair-stepped group delay, and then modulated group delay, and a probabilistic group delay. In each type, there are many kinds of examples, but for this presentation, I only take one from each type because I don't have many slides to spare. I'm sorry. I also present the mathematical expression of each trajectory like this. But for the probabilistic all-pass filter, I don't have any mathematical expression to present since it is probabilistic and it isn't presented in the paper either. So yeah. Okay, next I would like to talk about equalization. Equalization is the process of equalizing the amplitude of each harmonics in the Fourier series so that the input and the output has the same gain. Well, theoretically, all-pass filter has unity gain across all frequency, but since the slope of the group delay determines the amount of frequency spreading, the more spread frequency, the lower the instantaneous amplitude is. So we need equalization filter to circumvent this. And fortunately, in this paper, the equalization filter is presented. It has this kind of mathematical formula. Okay, next. Summary. All-pass filter has unity gain. Phase of each sinusoidal signal is shifted by the group delay trajectory, and equalization filter is required to ensure that there are no amplitude shift in the harmonics of the signal. Okay, let's talk about the secondary paper. Its title is Signal Decorrelation Using Perceptually Informed All-Pass Filter. It is from the 19th International Conference on Digital Audio Effects from the year 2016. Okay, first, the correlation is a stereo shaping process, meaning the process of creating and manipulating phantom source from a stereo or more complex audio system. First, what is phantom source? Phantom source is like when you are listening from a headphone or a pair of stereo active speaker system. You could hear that a mono audio signal will sound like it came from between those two speakers. Or when you are listening from a headphone, like this one, you could hear that the sound is coming from the middle of these two speakers, meaning it is sounding it sounds like it is positioned in the middle of your face, like around this one, like around this around like that. And usually The correlation is used for upmixing from 2.0 system to higher system, with a point O denotes the point O here denotes the number of subwoofer exists in the system. Like 5.1 means there are 5 speakers and 1 subwoofer. 7.1 means there are 7 speakers and 1 subwoofer, and etc. The all-pass filter used for the correlation in this paper presented is a Piquat all-pass filter with a transfer function like this, and the row here, the row symbol here is this. The pole zero angle controls the frequency at which the slope of the phase response change fastest. So yeah, the angle determines the frequency at at which harmonic does it does the slope of the phase response change fastest, and the pole zero radii control the amount of phase change. The results: the correlated signal using all-pass filter approach is less colored than other approach. Yes, in this paper, other approach is also presented, but since it will take too long and too many slides to explain, yeah, I'm sorry. This happens because each frequency doesn't undergo amplitude change. Yeah, it's pretty self-explanatory. In summary, the correlation is used to process mono audio signal into stereo or to upmix a stereo signal into more audio channel system, such as 5.1 or 7.1. The amount of phase change and the phase shifted frequency depends on the pole zero radii and angle. Yeah. Okay, that's all for this time. Thank you very much.